Hello students, today we are going to discuss a very important topic of class 11, which is trigonometric functions. In the first part we are going to discuss the units for measuring angles with examples and also JEE questions. So watch the video till the end. Some definitions. The word trigonometry is derived from the Greek words trigon and metron, and it means measuring the sides of a triangle. We define an angle. Angle is a measure of rotation of a given ray about its initial point. The original ray is called the initial side, and the final position of the ray after rotation is called the terminal side of the angle. And the point of rotation is called the vertex. You can see in the diagram, you have the initial side. After rotating, it goes to the terminal side. Now, if the direction of rotation is anti-clockwise, the angle is said to be positive. You can see in the first diagram. And if the direction of rotation is clockwise, then the angle is negative. The units for measuring angles. There are many units for measuring angles. The measure of an angle is the amount of rotation performed to get the terminal side from the initial side. Now, the first measure, if we say it is revolution, for example, the wheels of the vehicle are making an angles of say 25 revolutions per second. The second way how we can measure an angle is by degrees, the degree measure. If a rotation from the initial side to the terminal side is 1/360th of a revolution, the angle is said to have a measure of 1 degree, and it is written as 1 degree. You know that for a circle 360 degrees total. So if the rotation made is 1/360th of the revolution, then it is 1 degree. A degree is divided into 60 minutes and a minute is divided into 60 seconds. 1/60th of a degree is called a minute and 1/60th of a minute is called a second. And this is how it is denoted. In cases you can see in the first one, from the initial to the terminal, both the rays are same. So total 360 degrees. Now if the initial ray to the terminal ray in the second figure is there, then it is 180 degree. In the third figure from A to B, OA is the initial and OB is the final. So the angle made is 270 degree. Now suppose if it goes in the clockwise direction, we know it will be negative. So from OA to OB in the fourth case, it is minus 30 degree angle. Similarly, after performing one whole revolution, again it goes further. Here you can see it goes further after one revolution in the clockwise direction. So the angle total made is minus 420 degree. Next important unit for measuring angles is the radian. Angle subtended at the center by an arc of length 1 unit in a unit circle, that means circle of radius 1 unit, is said to have a measure of 1 radian. You can see in the first diagram, for the unit circle means the circle of radius 1 unit, if the angle subtended at the center is by an arc also of length 1 unit, then you say that 1 radian measure. In a circle of radius r, an arc of length r will subtend an angle of 1 radian. An arc of length L will subtend an angle whose measure is L by r radian. Correct? An arc of length L will subtend an angle whose measure is L by r radian. As equal arcs of a circle subtend equal angles at the center. So we have a very important formula, which is the angle made theta is equal to L upon r, length of the arc upon radius, or L is equal to r theta. Let's understand some angles with radian measure. In the first case, we know that for the unit circle means the circle has radius 1, and if the arc AB is also of 1 unit, then it is making an angle of 1 radian. If it is in the clockwise direction, similarly it will be minus 1 radian. Now in the third case, again you have the unit circle with radius 1, but the length of the arc AB is say 1.5 units. Then what will be the angle made? theta is equal to L by R. Length of the arc is 1.5 upon R, which is 1. So it will make an angle of 1.5 radian. In the fourth case, same way, since it is in the anti-clockwise direction, we have negative sign. This is important. Relation between degree and radian. Since a circle subtends at the center an angle whose radian measure is 2 pi and the degree measure is 360 degree. We know 360 degree is 2 pi, correct? So pi radian is equal to 180 degree. So suppose if I want, say for example 1 degree, then 1 degree is pi upon 180 radian. Or if you put the value of pi, it is 0.01746 radian. Now very important formula, radian measure is equal to pi upon 180 into the degree measure. Means if you are given degree measure and if you want to find the radian measure, multiply the degree measure by pi upon 180. And conversely, degree measure is equal to 180 upon pi into the radian measure. Now relation between degree and radian measures of some common angles are shown in the given table, and we will discuss more examples based on this. This is important. Example 1. Convert 40 degree 20 minutes into radian measure. Now we know that radian measure is equal to pi upon 180 into degree measure. Now first of all 40 degree 20 minutes. So 20 minutes we'll have to again convert into degree. So we know that 60 minutes make 1 degree. So 20 minutes is equal to 20 upon 60 degree, or 40 degree 20 minutes can be written as 41 upon 3 degrees. So now radian measure is equal to pi upon 180 into 41 upon 3. So pi upon 180 into 41 upon 3 is 40 into 3 plus 1 means 121 upon 3. When you simplify it, you get that as 121 upon 540 pi radian. Second example is you have to convert 6 radians into degree measure. See the calculations very carefully. Now first of all we know that degree is equal to 180 upon pi into radian measure. So 180 upon pi into how many radians we are given? 6. So 180 upon pi into 6 is 1080 upon pi. Put the value of pi as 22 by 7. So 1080 upon 22 by 7. When you simplify that, you get that as 3780 upon 11. Now 3780 upon 11, divide 3780 by 11. So what you get? 343 remaining 7 upon 11. So this is equal to 343 7 upon 11 degree. Now since it is not in full figure, so 343 degree 7 upon 11 we convert into minutes. We know that 1 degree is 60 minutes. So 7 upon 11 degree is 7 upon 11 into 60. I have shown the calculations, that is equal to 420 by 11. When you divide 420 by 11, you get 38 2 by 11. So this is equal to 343 degree, 38 minutes, and now 2 by 11 minutes we convert into seconds. So 2 by 11 into 60, which gives 120 by 11. Which is approximately 10.9. So now we have ultimately 343 degree, 38 minutes and 10.9 seconds. So the degree measure for 6 radians is approximately 343 degree, 38 minutes and 11 seconds. Example 3. Convert minus 47 degree 30 minutes into radian measure. We know that radian measure is pi upon 180 into degree. Now, how much degrees are given? Minus 47 degree 30 minutes. So again 30 minutes we'll have to convert into degrees. So 30 upon 60 degrees, which is minus 47 half degree. Pi upon 180 into minus 47 and half will give you minus 19 pi by 72 radians. Just simplify this, you will be getting this as minus 19 pi by 72 radian. Example 4. Convert 11 by 16 radians into degree measure. Now we know that degree is equal to 180 upon pi into radian. So 11 upon 16 radian is given to us. When we convert to degree, it is 180 upon pi into 11 by 16. Now again put the value of pi as 22 by 7. So ultimately in the numerator you will have 180 into 7 into 11, and in the denominator you will have 22 into 16. Simplify this, you will be getting as 315 upon 8 degree. But 315 upon 8 degree is 39 and 3 by 8 degree. So again, as I told you, degrees will have to convert into minutes. So 39 degree, 3 by 8 degree you convert into minutes. So 3 by 8 into 60, which gives you 45 by 2, which is again equal to 39 degree 22 minutes, and half again you convert to seconds. So half into 60. So ultimately your 11 by 16 radians is equal to 39 degree, 22 minutes and 30 seconds. A different type of example. Find the degree measure of the angle subtended at the center of a circle of radius 100 cm by an arc of length 22 cm. Use pi as 22 by 7. Now see what is given to us. A circle with radius r and angle which is made is theta. The radius is 100 cm and the length of the arc we denote it by L, that is given to be 22. Now we know the formula, angle is equal to theta is equal to L by R. So theta is equal to, what is the length of the arc? 22 upon what is the radius? 100. So 22 by 100 radian. Remember, this formula is for radians. If you need in degree, you will have to convert it to degree. So theta we have got 22 by 100 radian, but we need the measure in degree. So we know degree is equal to 180 upon pi into radian. So 180 upon pi into how many radians? 22 by 100. So put the value of pi and simplify, you get this as 63 upon 5 degree. So again, what is 63 upon 5? 12, 3 by 5 degree. So 12 degree, 3 by 5 convert to minutes. So 3 by 5 into 60, which gives you 36 minutes. So the required angle in degree measure is 12 degree and 36 minutes. Example 6. If in two circles arcs of the same length subtend angles 60 degree and 75 degree at the center, find the ratio of their radii. So what is given to us is two circles and the length of the arc is same, means L is same. What are the different angles? 60 degree and 75 degree. So we have to find the corresponding ratio of the radii R1 and R2. Let R1 and R2 be the radii of the two circles. So first of all, we know that the formula works in radian. So first we convert both the degree measures into radian. 60 degree is equal to pi upon 180 into 60 radians, which is 1 upon 3 pi radian. Similarly, 75 degree is pi upon 180 into 75 or 5 upon 12 pi radian. Now what is the formula? L is equal to r theta. As I said, L is same, the length of the arcs of same length, so L is same. So R1 theta 1 is equal to R2 theta 2. Since L1 and L2 are same, so R1 theta 1 is equal to R2 theta 2. R1 into 1 by 3 pi is equal to R2 into 5 by 12 pi. Pi getting cancelled, we get R1 upon R2. Bring R2 on this side. So R1 upon R2 is 5 upon 12 upon 1 upon 3. Simplifying, we get that as 5 upon 4. So the ratio R1 is to R2 is 5 is to 4. Example 7. Find the angle in radian through which a pendulum swings if its length is 75 cm and the tip describes an arc of length 10 cm. See, I have drawn how the pendulum will swing. It is given that it makes an arc of length 10 cm. Length of the arc L is 10 cm. We have to find the angle theta. So theta is equal to L by R radian. What is R? R is given to be 75 because the length of the pendulum is nothing but the radius of the circle. So theta is equal to 10 upon 75 or 2 by 15 radian. Since we want the answer in radian, we don't need to do any other conversion. So the angle made by the pendulum is 2 by 15 radian. Next example. This was asked in JEE. As I said, we will also discuss examples which were previously asked in JEE to get an idea of the same. The minute hand of a watch is 1.5 centimeter long. How far does its tip move in 40 minutes? Now imagine a watch and the minute hand is 1.5 centimeter long. So what does that show? If you see that as a circle, the radius is 1.5 centimeter. We have to find how far does it move. Means we have to find the length of the arc, which is r into theta. Now for this we have r, but we need to find theta, that means the angle it makes. So we have to find the angle it makes in 40 minutes. We know that 1 hour means 60 minutes. What is the total revolution? It is 360 degree. So 60 minutes means 360 degree we have. So in 40 minutes, how many degrees? So it is 360 into 40 by 60, which is equal to 240 degree. This point is important. Since 60 minutes, 360 degree, correct? 1 revolution. So 40 minutes, how many degrees? Cross multiply 40 into 360 upon 60, which is 240 degree. Now we convert degree to radians. Again, I am repeating the formula. We use it in radians. So 240 degree we convert into radians. Radian is equal to pi by 180 into degree. So pi by 180 into 240, which is equal to 4 pi by 3 radians. So now by the formula L is equal to r into theta, or 1.5 into 4 pi by 3, which is equal to 2 pi. Put the value of pi as 3.14. So you get the answer as 6.28 centimeter. So the tip will move a length of 6.28 centimeter in 40 minutes. Next example. Again, this is a different type of example. It was asked in JEE. The central angles of 4 sectors in degrees of a pie chart are P, Q, R and S. They satisfy the relation 9P is equal to 3Q is equal to 2R is equal to 6S. What is the value of 4P minus Q? Now you know that in a pie chart, all the sectors are divided in a circle. You can divide a circle into the required number of sectors. So I have just demonstrated a pie chart. Now the total, since it is a circle, the total measure is 360 degree. So the total of all the sectors P plus Q plus R plus S is equal to 360 degree. Now since we need the value of P and Q, we can convert it in terms of any one of them. So we convert all the angles in terms of P. P plus Q. What is Q? 9P is equal to 3Q. So Q is equal to 9 by 3P. Similarly, R is equal to 9 by 2P. And S is equal to 9 by 6P. So putting in the equation, we get value of P as 36 degree. What is Q? We know that Q is 9 by 3P. Correct, or 3P, which is 108 degrees. So 4P minus Q, when you simplify it, you get the answer as 36 degree. So 4P minus Q is 36 degree. Some assignment examples. Please do these examples. You'll get a clear idea of this topic. First one, how many radians are there in 1 degree? It is 0.01746. To get this exact value, you can take pi as 3.1416. This is a simple one. Second one, if the arcs of the same lengths in two circles subtend angles of 65 degree and 110 degree at the center, find the ratio of their radii. We have done a similar example. Here the answer is the ratio of radii is 22:13. Third one, if the angles of a triangle are in the ratio 2:3:7, then find the largest angle. The total of the angles is 180 degree. Accordingly, you can find the largest angle, which will be 105 degree. Fourth one, a wheel makes 12 revolutions in 1 minute. Find the angle in radian described by a spoke of a wheel in 1 second. In 1 minute, it makes 12 revolutions. You have to find the angle in radians, remember, for 1 second. The answer is 2 pi by 5 or 2 by 5 pi. Now the hint over here is the distance covered by the wheel in 1 revolution is how much? The whole circumference of a circle, and it is given by circumference of a circle is given by 2 pi r. So for 1 revolution it is 2 pi r. You can find for 12 revolutions, and then when you find the angle, you will be getting it as 2 by 5 pi. In case of any query, please put in the comment section. This part we have discussed the units of measuring angles, basically degrees and radians, and all the examples based on it. In the next part we will see very important thing, which is the trigonometric functions. Please do like and share the video and subscribe to the channel. Thank you.